Lesson 3.3, Video 3. Radical functions. Now, radical is a fancy word for square root, cube root, and so on. So if you look at the function, notice that there is a square root. Now, the variable is inside the square root, and the result of such a thing is a curve. But it's a very interesting curve because if you look at the picture that's given, it starts at 0, 0. It doesn't go into the negatives, and then it has this, it seems to go up, but then it kind of flattens out a little bit. And that's what a radical function looks like. Now, it's important to understand that the reason it doesn't go negative is because you cannot plug in, or you can't root negative numbers. Now, we're going to get into square rooting negative numbers, but it involves something called imaginary numbers, and we're not there yet. So basically, at face value, we can't plug in negative numbers into the root. It's an error. So that's why our graph looks the way it does. So in other words, our domain in this particular case, in this graph, our domain would be x values that are greater than or equal to 0 in this particular case. Next would be reciprocals. If you remember the vocabulary of reciprocal, if I give you y equals x as a function, I can write x as x over 1. So the reciprocal would be 1 over x. So in other words, if I have a table for x and y and I plug in a 1, the reciprocal of that is 1. If I plug in a 2, and I'm talking about plugging into this function, I get 1/2. If I plug in a 3, I get 1/3. If I plug in a -3, I get -1/3. So basically I'm just creating reciprocals from that function, hence the title reciprocal function. But it does give us an interesting graph. So if we look at this, notice that there's two separate graphs. One is in quadrant 1 and one is in quadrant 3. So that's just an observation. And for future reference, these lines right here are lines that are called asymptotes, which means they approach. Our red lines approach those lines but never cross. So they kind of create a boundary. Alright, conjecture. A conjecture is an opinion or theory so formed or expressed, guessed, or considered speculation. And the reason we have that vocabulary word is, will come up later. But when we talk about graphing all of these kinds of functions, it is key to understand that we should, most of the time, unless it's a very obvious graph, make a table. And that's what I've done here in a couple of these. Also, and then once you have your table, plot the points and connect the dots. Okay, so we're going back to some very fundamental ideas in terms of how we graph. And when I say that, I mean using a table, because we've done a lot with trying to be efficient in graphing with slope-intercept form and all those things. But when we're graphing these types of functions, we really need to go back to the basics of graphing with a table, so that we get the graph right. It's one of the best ways of creating these graphs. And just for food for thought, it's always good to plug in some positive values and some negative values. Because as you've seen, sometimes the function will affect negatives differently than positives. Case in point being absolute value. Alright, so for example, if I had an absolute value function and I only plugged in positives, I would think, incorrectly of course, that if I only plugged in values over here, then my graph would look like this, and I would assume incorrectly that it would continue on, and that's what happens. But if you were to plug in some negatives, you realize that it actually bends upward again, or it's a straight line going upward. So very important to plug in some positives and some negatives, because they are affected differently sometimes in the function you have. And this ends Lesson 3.3, Video 3.